Good evening students. Today I am going to discussing oxidation state or oxidation number from redox reactions and how to calculate the oxidation number of a central atom in given compound and also go for the previous year JEE and NEET questions. Okay. Now first of all, what is oxidation state? Oxidation state or oxidation number. Okay. Now, how to define the oxidation state or oxidation number? The charge present on an atom in combined state or uncombined state is nothing but oxidation number or oxidation state. So, repeat once. The charge present on an atom in combined state or uncombined state is nothing but oxidation number or oxidation state. It is a real charge. It is real charge in ionic compounds. Ionic compounds. But imaginary charge in covalent compounds. If you see the in covalent compounds, an atom with the highest electronegative is taken as -1 oxidation state. Atom with highest electronegative is given as minus or negative oxidation state, and an atom with the lowest electronegativity is given as positive oxidation state. Okay. Before going the calculation of oxidation state of an atom, central atom in given compound, you have to go for some rules. What are the rules here? Now, rule number 1. The oxidation of an atom in uncombined state is always 0. For example, sodium, potassium, okay, magnesium, calcium, like hydrogen, nitrogen, oxygen, okay, ozone, even fluorine, chlorine, etc. Oxidation number is 0 because they are all elementary form and homogeneous molecule exhibit by 0 oxidation number. Let's go for the rule number 2. For monoatomic ions, the oxidation number is nothing but equal to charge present on ion. For example, sodium ion Na plus I, what oxidation number here? Plus 1. In case calcium ion Ca2 plus oxidation number is plus 2. Like fluoride ion, oxidation number is -1. Oxide ion O2 minus, oxidation number is -2, etc. Okay. Next, when you go for the rule number 3, the sum of the oxidation state of all atoms in a molecule is 0. For example, sulfuric acid, H2S from taking here. Now, oxidation state of hydrogen taking as X, sulfur taking as Y, oxygen taking as Z. The sum of the X plus Y plus Z is nothing but 0 because the sum of the oxidation of hydrogen, sulfur, oxygen total equal to 0 because it is neutral molecule. Okay. Let's go for the rule number 4. For polyatomic ions, okay, the sum of the oxidation of all elements is nothing but equal to charge present on the ion. For example, carbon ion CO3 2 minus. Now, oxygen carbon taken as X carbon and oxygen taken as Y. The sum of the X plus Y equal to what is charge present here? -2. Then X plus Y equal to -2. Okay, rule number 4. Coming to rule number 5. What rule number 5 here? The oxidation of fluorine is always exhibited by -1, always -1, because the highest electronegative element entire periodic table is fluorine. Then only fluorine can form only one covalent bond. That's always -1 in the compound. number 6. Oxidation state of iodine exhibit by +1 in their compounds except metal hydrides. Except the metal hydrides. In metal hydrides, iodine exhibit by -1. Other than metal hydrides, the oxidation state of iodine is +1. That is the rule number 6. Next, go for the rule number 7. Rule number 7 here. Oxidation state of oxygen exhibit by -2 in their compounds except peroxides, superoxides and fluorides. Peroxides, superoxides and fluorides. Okay, if we take the peroxides, in peroxides, oxidation of oxygen exhibit by -1. You see the example of these: hydrogen peroxide HuO2, sodium peroxide Na2O2, barium peroxide BaO2, etc. Here, oxidation of oxygen, hydrogen peroxide -1, here also -1, here also -1. Any peroxides, the oxidation of oxygen is the -1. Next, go for the superoxides. In superoxides, oxidation state of oxygen is the -1/2. For example, take here potassium superoxide KO2, rubidium superoxide RbO2. In this case, what happened? Oxidation of oxygen is always -1/2. This superoxide means oxidation of oxygen is -1/2. Okay, and coming to fluorides. In fluorides, oxygen exhibit by either +1 or +2 also, based on the fluorine with oxygen. For example, take here in O2F2, dioxygen difluoride and oxygen difluoride. Take here. In this case, fluorine always -1. Then -1 into -2 is the +2. +2/2 is +1. In this case, oxygen is +1. Second case, what happened? Oxygen is +2 because fluorine is -1 into -2 is the +2. Okay, only with the oxygen only fluorine can form compound like this and they exhibit by +1 +2. Right, students? This is the oxidation of oxygen in different cases. Normal oxygen will be -2. Okay, peroxide is exhibit by -1. Superoxide is -1/2. Whereas fluorides +1 in O2F2, whereas +2 in OF2. That is rule number 7. Now coming to rule number 8. The oxidation state of all first group elements exhibit by +1. Always first group element by +1 and second group element exhibit by +2. Okay, that rule number 8. And rule number 9. Any element exhibit highest oxidation state. Any element exhibit highest oxidation number is nothing but equal to group number. Equal to group number. Other than group number not exhibit. Highest is the maximum group number only. And finally, one more important rule is there. This is very important when you go for second year coordinate compounds also. Okay. What is the oxidation of metal is 0. For each compound exhibit by 0 oxidation number. We take in amalgams and also alloys, amalgams and metal carbonyls. Metal exhibit 0 oxidation state. Keep in mind. Okay, any metal carbonyls so very important second year coordinate compounds. Any metal carbonyls metal exhibit 0 as well as amalgams also 0, alloys also 0. For example, you want to give some example of these compound. Alloys and taking an example, brass. What is the formula of brass here? Copper plus zinc is nothing but brass. Now oxygen and carbon, zinc, both of them equal 0. Amalgam, taking an example, sodium amalgam, NaHC. Both metals exhibit by 0 oxidation number. Similarly, go for some metal carbonyls. Nickel tetracarbonyl, metal oxidation number is 0. Similarly, iron pentacarbonyl, the oxidation number of ion here 0, etc. So these are the some some important rules to find out the oxidation number of central atom in a given compound. Now go for some previous questions either JEE or NEET. We see the first question for JEE level. Previous JEE exam they asked here, which of the halide does not exhibit there? Which of the following halogen does not exhibit variable oxygen state? Variable oxygen state. Options: option A fluorine, option B chlorine, option C bromine, option D iodine. You see here, easy. That is the question. Does not exhibit amount. Here fluorine exhibit only -1 always, but remaining exhibit different oxide numbers variable. For example, chlorine exhibit by -1, +1, +3, +5, even +7 also they compounds. But fluorine always exhibit -1. Then only answer is the A. Remaining are exhibit other than -1, -1, +1, +3, +5 all exhibit. Okay, this is the one of the important question previous exam. And also one more question here. This also previous JEE, last JEE only, and shift one on 27th exam. But the question here, how many of the following have +4 oxygen states? How many following have the +4 oxygen state? +4 oxygen state. Okay. How many of the following have the +4 oxygen state? Given here, barium sulfate. Okay. Like go for the SOCl to iron chloride, SF4 sulfur tetrafluoride. Next go for the SO3. Next H2, O7, SO3. These compounds given. Among these compounds, how many compounds are exhibited by +4 oxidation number? How to find out? See here, for example, counting sulfur exhibit. What oxidation number? Now barium +2 plus sulfur is X plus oxygen here 4 are there. 4 into -2 total compound 0 neutral compound. Then how to calculate? 2 minus 8 minus 6. X minus 6 equal 0. X equal to 6. Okay. Like coming to here, what are we have? Oxygen is -2, fluorine -1. -1 into -2. This is -2. -2 -2. -4. -4 sulfur is the +4. Yes, this is correct. But this is +4. Next coming to here, fluorine -1 always. -1 into -4. Sulfur is the +4. Yes, sir. Sulfur trioxide oxygen -2 into 3 -6. Right? Sorry. H2SO3. Okay. Now sulfur -2 into 3 -6 plus 2 is equal to +4. Yes. Next this one, how to find out in case you don't like taking in 2 into +1 plus 2 into x 2x plus 7 into -2 equal to 0. Then 2 minus 14 12. 2x equal to +12. Then x equal to +6. Then it's wrong. +6 wrong. And here -2 into 3 -6. So that's also the +6. This also only second one, third one, fourth one. The answer is the 3. Option of +4 exhibited by compounds among these only 3 is the answer. Okay. And also previous last 2020 NEET question, I'll give that also. See here, NEET 2020. Okay, what is that here? What is the change in oxidation state of? What is the change in oxidation state of carbon in the following reaction? The following reaction. What is the reaction given here? Methane when react with chlorine to get CCl4 plus 4 moles of HCl. Now what is the oxygen number carbon in this methane to carbon in carbon tetrachloride? Okay, the given options, option A 0 to -4, option B -4 to +4, option C 0 to +4, and option D +4 to -4. This is the easy. Okay, actually what is the oxygen number of carbon in this methane? It is +1. +1 into 4 +4, then carbon is the -4. Here chlorine is -1 generally. -1 into 4 -4. -4 to carbon +4. See, -4 to +4. Answer is the option B. Previous last 2020 NEET question. And also they asked what is the oxygen number of chromium pentoxide? JE question on 29th morning session they asked. But that is asking based on the D and Diploid elements concept and what they asked the question that. Okay, what is the JE? Okay, first of all, you know already any sodium chlorine salt react with potassium dichromate in presence of sulfuric acid, they giving chromyl chloride. Chromyl chloride react with any base to give the chromate ion, yellow color chromate ion is formed. Okay, yellow color chromate ion again further estimation in presence of amyl alcohol as well as 10% H2O2 to give CrO5 chromium pentoxide form. Now what is the oxygen of chromium? Chromium pentoxide. That's the question. Okay, indirectly like upcoming already they ask question. Okay, what is the oxygen of chromium? Chromium pentoxide. Generally you can apply method what are here? Take X. Then 5 oxygens are there, 5 into -2 equal to 0. Then X minus 10 equal to 0. Then X equal to less than. Okay, correct or wrong? Because in this chromium pentoxide total 5 oxygens are there. Out of 5 oxygens only one is the normal. Remaining 4 are the peroxyl oxygen. I am giving this one. This is the structure of that one, like a butterfly structure. This is the structure of chromium pentoxide. Okay. Now any peroxide, these two peroxide is called peroxide. Any peroxide exhibit by -1 oxygen number and normal is -2. See here -1, -1, -2, -3, -4 and -2. -3. Chromium is the +6. Then oxygen number of chromium is the +6, not +10. Very important. Okay, like that we see the some more examples how to find out the oxidation number of central atom of given compound. We see some examples. For example, oxidation state of sulfur in carous acid. Very important. Carous acid. Sometimes we will just name. Carous is nothing but what is the chemical name? Peroxymonosulfuric acid. Peroxymonosulfuric acid is nothing but carous acid. Then what is the formula of carous acid here? H2SO5. What oxygen number of sulfur here? That you can apply this one to get +8. Wrong. Why here? Sulfur exhibit maximum +6 only. You see the structure of this one. H bond O, S double bond O, double bond O, bond O, bond O, H. These two are peroxy. Out of 5 oxygens, so 2 are the peroxy. Then only -1, -1. Remaining oxygen exhibit by -2 oxidation number. Add it +1, +1. Apply here what happened? 2 plus X plus out of 5 oxygens, so 3 are the normal -2 oxygen number. Remaining 2 are the peroxy oxygen number exhibit by -1 oxygen number equal to 0. Now +2 -2 cancel each other. Then X minus 6 equal to 0. X equal to +6. That you can apply hence to get the +8. Wrong. Oxygen of sulfur in carous is +6 only. Right students? Similarly go for the oxygen state of more example giving here. Second example, oxygen state of sulfur in Marshall's acid. Marshall's acid. What is the Marshall's acid here? They will give some direct name. What is the first of all chemical name Marshall's acid? This is the peroxy disulfuric acid. Peroxy disulfuric acid, nothing but Marshall's acid. What is the formula of Marshall's acid here? H2S2O8. What is the oxygen of sulfur in Marshall's acid? How to calculate? You see the structure of this one. Here peroxy means the 2 oxygens peroxy is there out of 8 oxygens. You see the structure. H bond O, S double bond O, double bond O, bond O, bond O, S double bond O, double bond O, bond O, H. Out of 8 oxygens, so these two are the peroxy. Then only exhibit by -1 oxidation number. Okay. and remaining carbon oxygen secreted by -2. You have to count. Okay, iodine is a +1. See here, out of 8, how many peroxide? 2 is the peroxide. Remaining 6 are the normal. Then only 2 into +1 iodine plus 2x plus 6 into -2 plus 2 into -1 equal to 0. Okay, here 2 plus 2x plus 6 into -2 plus 2 into -1 equal to 0. The plus 2 minus 2 cancel each other, and then here 2x equal to 6 into 2 minus 12 going that side equal to plus 12, and then x equal to plus 6. Okay, now the oxygen number of sulfur in mass of acid also plus 6 only. Right students, like that you can see the one more example. Oxygen state of carbon in carbon suboxide. Carbon suboxide. What is the formula of carbon suboxide? First of all, very important is also formula of carbon suboxide is C3O2. What is the carbon? That you can apply. The 3 carbons are there. I want carbon oxygen number 3x plus 2 into -2 equal to 0. Then 3x equal to plus 4. 3x equal to plus 4, and finally x equal to plus 4 by 3. Okay. Sometimes not asking average oxidation number. What is the oxidation number of second carbon suboxide? You can see the structure of carbon suboxide. CO, C double bond, O double bond, C double bond, C double bond, C double bond. This is the structure of carbon suboxide. With respect to oxygen, oxygen -2, carbon +2. Here oxygen -2, carbon +2. And middle carbon is 0. Right students? -2 +2 cancel each other. This of cancel, finally middle carbon oxygen 0. Some will ask question like, what is the oxygen number of middle carbon suboxide or second carbon suboxide is 0. Very important. Like this way to find out the oxidation number of any central atom given compound. Similarly, go for the any complex compounds also have to find out the oxidation number. Very important. Second year, what is compounds? How to find out the oxidation number given any complex compound also. Right students? Thank you.